Alright, as we go through this, whoever is sitting closest to the board, when the time is appropriate, jump up, grab a pen, and pause it. So we're going to pause quite a bit through this tutorial. And if you need to rewind it, if we're going too fast, you can get up and stop and control the board. So let's talk about polynomial functions. Chapter 7, 7.1. If we understand the general shape of what a polynomial function looks like and then how to evaluate them, we'll call it a day. We'll be in good shape. So let's review. Polynomial. What is a polynomial in one variable? So polynomial, here's an example. It's like 3x squared plus 2. Remember, if there's two terms like we've got here, we call it a binomial. If there's three terms, it's a trinomial. But all a polynomial is in one variable, so there can only be one letter. So this is not 3x squared y plus 2. This is bad because there's two letters. And then it's just a combination of numbers. This is your constant right here. You're adding terms together. 3x squared plus 2, those two terms. So you're just adding terms. Alright, so rearrange this polynomial into standard form. Standard form is this. Standard form is when your exponents decrease from the left to the right. So this right now needs to be simplified. Before you can do anything, you gotta evaluate it, simplify it. So it's a multiplication problem. Let's do 3x squared times 2x squared. That's going to be 6x to the fourth. 3x squared times a negative 9 is a negative 27 x squared. Then 1 times 2x squared is going to be 2x squared, and 1 times negative 9 is going to be a negative 9. And then you can go one step further. Combine your like terms. So 6x to the fourth and a minus 27x squared and a positive 2x squared is going to be a negative 25x squared minus 9. And I think we've got it. I think that's it right there. So your polynomial happens to have three terms: 6x to the fourth, a negative 25x squared, and a negative 9. So we're going to call that a trinomial to be specific. But this chart down here, in this column we've got the names of your polynomials, and the expression, that's just what it looks like, kind of like the problem, the degree, and your leading coefficient. So let's see if we can figure it out. So the first one, if you ever come across this expression, if you ever come across just a number with no letters, that's just called a constant. The degree is the exponent. So the degree is the exponent. So there's not an exponent because there's no letter with it, no variable. Okay, the coefficient. The leading coefficient is the number in front of the letter. So let's look at a linear one. This is where you spend all of your pre-algebra and algebra. X minus 2. X minus 2, there's kind of two terms. That's a polynomial with two terms. So the degree, the 1, where you see the 1 is right here. It's x to the 1 minus 2. The leading coefficient is 1. That is the number in front of your very first term. So let's look at a quadratic. We just finished up quadratics. 3x squared plus 4x minus 5. The degree is 2 because my exponent is 2. And then the leading coefficient is 3 because that's the number in front of my first term. So hopefully that chart makes sense. Let's go to slide 2. Alright, let's practice. So find the degree, state the degree and the leading coefficient of each polynomial. So we got 4 practice problems, A, B, C, D. If it's not a polynomial in one variable, explain why. So whoever's close to the board, why don't you jump up and pause it. You guys take 5 minutes and see if you can do these on your own, and then resume it, and we'll check your answers. Okay, A. The degree is the highest exponent, so the degree is going to be 4, and then the leading coefficient, that's part, I guess I'll say this is part 1 and part 2. The leading coefficient is this guy right here, 7. B, it's kind of a trick question. There's an x and a y, so this is not a polynomial in one variable. So that's all you got to put, and you're done. Can't do much to it. 3, or C, is kind of a trick question too. C is not a polynomial at all. And let's review what is a polynomial and what's not. Okay, if you have this, this guy is what's messing it up. You cannot have any letters in the denominator. You cannot have any letters under a radical. And you cannot have any letters that have negative exponents. So these 3 stipulations right here, if you ever come across one of these 3, it is not a polynomial. So C is not a polynomial. Okay, D, the trinomial needs to be rewritten. It's out of order. It needs to be negative x to the 5th. That's your highest exponent, and then go from descending order. So the next one's going to be 2x cubed plus 1/2 x squared. So now it's in standard form, highest exponent to the lowest. So my degree, part 1, the degree is the exponent, so this is a quintic, it's a degree 5. 2, your leading coefficient is the -1. It's the number in front of the x to the 5th, negative x to the 5th. And let's do slide 3. Okay, let's talk about a polynomial function. A polynomial function is just an equation, like y equals mx plus b. That's the famous linear equation, the function form. All you really need to know out of this, the general definition of a polynomial function looks like this. It's kind of technical and hard to read, but the examples are pretty good. So we're going to use this right here. We're going to use function notation from now on. F of x, or they got right here p of x, just for polynomial. P stands for polynomial. But remember, f of x is the exact same thing as y. So it's really y equals 4x squared minus 3x plus 2, and then they tell you the n in this guy, that's just the exponent, so the n is 2. A to the sub-0, that's the leading coefficient, so the leading coefficient's 4. So you just kind of see how they match up. But we need to remember, we're going to use function notation, and remember that's the same thing as y. So evaluating polynomial functions, find p of 3 and p of a -1 for each function. So p of x, this is the function notation, this is the same thing as y, and what they really want you to do is make a table, an xy table. But they're telling you 3 needs to get subbed in place of x. So they want to know, let's put 3 in for x, and what does this formula spit out for y? Let's put -1 in for x, and what does y give us? What does it spit out? So replace a 3 here and replace a 3 here. So it's going to be 2 times 3 cubed. Now you got to do that very first. 6 times 3 minus 12. So you got to do 3 times 3 times 3. That's 27. 27 times 2. This is going to give us 54. 6 times 3 is 18 minus 12. So 54 plus 18 minus 12. I think it's going to end up at 60 if we did it right. Okay, let's try. Let's sub in -1. Okay, now this is going to get tricky. 2 times, let me change colors, 2 times a -1 cubed plus 6 times a -1 minus 12. So you got to do the exponent first. You have to do -1 times a -1 times a -1, which is going to be a -1. 2 times a -1 is just a -2, so we're going to have a -2 plus a -6 minus 12. And I think a -2, a -6, and -12 is a -20. So your answer is going to be written like this. P of 3 is going to give me 60, and P of a -1 is going to give us a -20. So that's how we write it. Okay, now you guys try, see if you can try. Well, you might not be ready to try these two. Let's work through these together. So you got two functions, p of x, and remember that's the same thing as y, equals -x cubed plus x squared minus x. Okay, this one's going to be a little abstract because they want you to plug in place of x, they want you to put a cubed. So it's kind of an abstract idea, and this first one's pretty tough. So let's do this. Let's put a cubed everywhere you're going to see an x. Now what's going to make this tough is the very first term, that -x cubed. What you need to remember is that cubed, that 3, is only going to the x. It has nothing to do with this negative out front. And if you make a mistake, you're going to make it right there. So that exponent's only going to the 3. So you're going to have a negative. And let's do this. Let's put parentheses around your x. So -x cubed plus parentheses x squared minus parentheses. Okay, here's your 3 x's. Now I'm going to substitute in place of those 3 x's a cubed. So I'm going to drop in a cubed here, and a cubed here, and an a cubed here. Okay, you got to remember your properties of exponents. If you're raising an exponent to another level, you multiply them. So this is really a to the 3 times 3. So it's going to be a to the 9th. A to the 9th. Now, bring this negative down. So your first term is a to the 9th. It's a -a to the 9th. Your next term, a cubed to the 2nd power, is a to the 3 times 2. So it's going to be a to the 6th. And your third term is done. Nothing really to do. So there you go. Your answer, when you sub in a cubed, so p to the a cubed equals a -a to the 9th plus a to the 6th minus a cubed. So it's not too bad. Let's try. I'm going to clear this off. Let's try this next one. Okay, your order of operations really kind of help. You've got to do the parentheses first. So what they are telling you to do is 5 multiplied q to the 2a. So it's kind of an abstract thing again. But what they want you to do is everywhere you see an x, let's replace it with a 2a. And there's only one x, so that's pretty nice. So let's do the parentheses again. So it's 5 times x squared plus 4. So in place of that x, first of all, I'm going to drop in this guy, this 2a. 2a. Okay, you got to do the exponents first. 2a squared is 2a times itself, 2a. So that simplifies and gives you 4a squared, and you need to times that guy by 5 and then add 4. So 5 times 4a squared, just multiply your numbers, that's 20a squared plus 4. Okay, we're done with this part right here. The last thing you need to do, it wants us to do 5 times whatever that was. So I'm going to do 5 times both of these terms. 5 times 20a squared, I end up with 100a squared plus 5 times 4 is 20, and that's my final answer. So 5 times the quantity q of 2a is equal to 100a squared plus 20. Alright, so that's the evaluating part. Evaluating, you're just making a table, you're just plugging in values. Now let's talk about what they're going to look like. Alright, so you have kind of a, this is the general case. The degree 0 is going to be a horizontal line. Degree 1, this is all your pre-al and algebra. They're lines with slope, steepness, y equals mx plus b. Degree 2, we just got done. A quadratic, that's a parabola. Now these next 3, degree 3, degree 4, degree 5. They are going to also have curves. And here's something kind of cool. Notice any relationship between the graph and the degree. So let's look at this degree 2. Degree 2 has how many curves? How many times does it change direction? It just has one curve. It changes direction once. Look at degree 3. How many curves does it have? It's got 2. It changes direction twice. A degree 5 is going to have 4 curves. It's going to change direction 4 times. If you can kind of see that. So 0 of a function. Let's talk about a 0. A 0, let's look at the quadratic. A 0, this has degree 2 has 2 chances for zeros. But remember, a quadratic does not have to go through the x-axis. If it has a parabola that looks like this, it still has two roots, 2 solutions, but they are not real numbers. They're imaginary solutions. But this one right here, this quadratic, goes through the x-axis 2 times, so it has 2 real solutions, and those are called your zeros. This guy right here, cubic, there's a 0, there's a 0. So it has, this one has 3 real zeros. Quartic, there's a 0, there's a 0, there's a 0. So these are your zeros of a function. A quintic, there's a 0, 1, 2, 3, 4. It goes through the x-axis 5 times. This particular one. They all don't, because look at this quadratic. This doesn't even go through the x-axis. But it could, at most, go through the x-axis twice. So quintic could, at most, go through the x-axis 5 times. So it'd give you 5 solutions, 5 roots, 5 zeros. Okay. End behavior of a polynomial function. We're not going to graph them, but we are going to know what they're going to look like, because there's a pattern between the evens and the odds. So all you need to know is the degree. So the degree of evens, that's like 2, 4, 6. So quadratic, a quartic, 6 degree. Odd, these are like linear, cubic, quintic, etc. So you look at the exponents, and let's talk about alright, the coefficient right here. If it's positive, if the leading coefficient, so that's your a, if your a is positive, the parabola opens up. If your a is negative, I guess we gotta come clear over to here, your parabola is gonna open down. So here's what's gonna happen as far as the end behavior. So you need to look at 2 things. If it is an even exponent, it's going to fit this type right here, every even exponent will fit this. And if your leading coefficient is positive, every polynomial function will fit this description right here. So here's an example. If you have, let's do an example. If you've got the 4x to the 8th power minus 5x. Okay, so if I ask you, well, what is the end behavior? What is it going to happen? It's asking what when you go right and when you go left, where are these arrows heading? What direction are they going? So it's even right here because the exponent's 8 and the leading coefficient is 4 and it's positive. So here's what happens. Okay, these f of x's, remember they're the same thing as y. So what this arrow says is approaching. So as x approaches positive infinity, that means your x-axis. So you go to the right, start at the origin, and as your x-axis goes to positive infinity, so as you work your way to the right, what happens to my graph? This graph is making his way to positive infinity. This parabola is going to go forever. So the more you go to the right, the further up on the y-axis this parabola goes, this graph goes. And the more you go to the left, as x approaches negative infinity, your parabola is going to approach a positive infinity. If that makes any sense. Okay, let's talk about odd ones. If your degree is odd, if the exponent is 1, 3, 5, 7, the further you go to the right on the x-axis, the further up your graph is going to go. So as x approaches infinity, your y is also going to approach infinity, your f of x. But now let's go to the left. As x approaches a negative infinity, your graph is going down, further down, 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 down. So your parabola, your f of x, this is not a parabola, but your graph is going to approach a negative infinity. So let's see if we can, let's practice on these right here. So maybe hop up, send someone up to the board, pause it, give yourself 5 minutes, and let's see if we can check your answers. Okay, A. Alright, let's see if we can figure out if this is, well, let's look at your bullets right here. The end behavior, let's do that. And let's just look at the picture. So, what happens the further you go to the right on your axis? It looks like your graph is going down, down, down. So let's say as f of x approaches a negative infinity, x approaches a positive infinity. So that's kind of shorthand notation for saying as x goes to the right, the further you get on the x number line, the further down your graph goes, the closer it gets to negative infinity. So the closer x gets to positive infinity, the closer f of x gets to negative infinity. Okay, let's do the left side. As f of x approaches a negative infinity, well, that's bad infinity, x is also approaching a negative infinity. So the further you go left on the x-axis, your graph is going down also. Okay, let's do B. Let's call this A, B, and C. B, is this an odd degree or an even degree? And maybe one way I tell is to see how many times does it change direction. So there's one curve, two curves, three curves. So if there's three curves, if it changes directions 3 times, this must be 4th degree. So it's even. Okay, the number of real zeros. The real zeros, this is an awesome question. The real zeros, where does this graph go through the x-axis? It only goes through the x-axis 2 times. These are your real zeros. Once there and once there. So if it's a fourth degree, if it's a quartic, there's going to be 4 answers, but only 2 of them are going to be real solutions. The other 2 are going to be in the set of complex numbers. Okay, B. Alright, B. Describe the end behavior. Let's do the first one. Okay, this looks like it's going up. So f of x is approaching infinity as x approaches infinity, and f of x is approaching a negative infinity as x approaches a negative infinity. Okay, is this an odd or even? How many times does it change direction? Once here and once here. There's 2 curves. So if there's 2 curves, it must be a degree 3. It must be a cubic. This is a cubic, so it's odd. The number of real zeros, this goes through the x-axis only 1 time. Okay, quickly on C. The end behavior, f of x approaches infinity as x approaches infinity, and f of x approaches a negative infinity as x no, that's a positive infinity. The left side, I'm looking at the left. This is, the further you go left on the x-axis, the further this goes up. So f of x approaches infinity as x approaches negative infinity. This is a quadratic, so it is an even. The real zeros, there are none. It doesn't go through the x-axis at all. Alright, that's it. Let's do your worksheet.